Hello, everyone. Welcome from across the globe. Um, the first part of the session, I'm going to talk about the Abacus Implicit Interface for HyperWorks 2022. Let me get on with the presentation and probably a little bit of demos in between as well. Um, First, I'm going to start with the new features introduction. Um, this new feature, which is the coupling constraint, is was originally supported in HM in more than one ways. Um, for example, this coupling constraint, when the constraint is a node-based surface, we had it on the 1D panel, rigid elements or RB3s in the 1D panel, and when the surface can be an element-based surface, like basically a set segment, um, we had that support in the group entity. And for that group entity, we did not have um, a display. So you would not be able to visualize these coupling constraints when we had a set segment or an element-based surface in the group entity. Now we have migrated the 1D panel constraint as well as um, the group entity-based one, both surface-based, node-based surface or element-based surface to a new constraint entity. And with the availability of new constraint entity, obviously you can see that you would be able to visualize for both of them. And as you can see, like the couple of keywords of the coupling constraint, one is kinematic, which is pretty close to the rigids, and the distributing is very close to the RB3s. Um, while the display is available, it obviously makes things little cluttered, or for most of the users. And for that, to ensure that the GUI is not cluttered, but at the same time, the viewer should be able to understand that there is some kind of a coupling constraint. We have introduced a preferential setting. In the preferential setting under appearance, you should be able to set the threshold level. So when the number of nodes or number of the I would rather say not nodes, the links. When the number of links is too cluttered and you want to have a more clear view, you can set the threshold level to a lower one. And depending upon the number, it would cut off anything above 100 number of links, and just show the put a box around that model where the constraints are applied, and uses the far edges of the box to say that there is a complete constraint. And on top of that, obviously, you also have show degree of freedom and weight labels. Degree of freedom, obviously, when there is, at the independent node, you would show what are the degrees of freedom that are constrained. In this case, I have 1, 2, and 3 constrained, and you can see that. And the weight labels, this comes for this RB3s, right? So the RB3s can have a weight label attached to each link, and you would be able to see the weight label. In this case, like if I'm doing it on the model with more number of nodes or element faces that are connected, you would see as many weight labels. Again, that could be cluttered. So, to get a fair idea, you can obviously, have, um, more clear view with the preferential option. Um, just to probably just give me a second, I will open up the HM session quickly. Um, you're seeing the same model here, which is a new constraint called the coupling constraint. That's the in the TOC browser, especially on that, I'm on the constraint tab, and all these coupling constraints are displayed here. The one that you're seeing is here, and as you can see that, we have a pretty good browser enabled and the entity editor based, setup and modification that probably is required. Um, and we also support the creation of set sets. Obviously, Abacus being a name-based solver, it allows to use the sets than the nodes directly. So you are able to create a set and be able to use that one for your referenced entities. So while doing this, I will also, try to show you the preferential setting here. Just as I showed you, you could see that, the maximum threshold has been, the default is always 10,000. And if I want to reduce it, I would be able to do so. And let me also turn on the DOFs. So now you would see like both the DOFs as well as the weight labels that are attached to this. Um, Let me take one more simple model just in the same screen and show you how this DOFs would help you. I mean, changing the weight labels is more intuitive rather. Let me take this model. You could see that I still have an RB3, which is having I think probably I did not set up the DOF here. So the moment I set up the DOFs, you would be able to see them as well. So all the DOFs are visualized, and you could see that weight labels are applied, which is common for the entire model. Nevertheless, sometimes with the RB3s, you might not want to have the same weighting factors, right? So we do have the distribution option, which can be turned from uniform to non-uniform. And once you change it to non-uniform, I do it in a different model, I guess. So let me do it here. I'll change it to the non-uniform. And now went to the other screen. You could see that you can change the weight labels for some of them to a different value if you'd like to. And it synchronizes with the graphics right away. So this new feature, I'm assuming that would help our users a lot in terms of one, better managing the constraint itself and the display. And along with the display, it's much more intuitive now for the users to be able to modify and visualize the same. So that's our the new entity migration for those coupling constraints, which were just to let you know, originally in the rigids panel and RB3 panels. Still, there are some left which are like not the node-based ones. I mean, basically a direct connection to the nodes, but this is surface-based coupling constraints that is migrated. And soon the phase 2 would proceed towards completely, replacing this 1D panel rigids and RB3s to the coupling constraint. And, we'll do it in phases as we go further. And it's not just Abacus, we would be doing it for other solvers as well, slowly and steadily, including the crash solvers. Let me move on to the next part of my presentation, component migration. Here, I want to take a little more time for the users to understand what is this and why we are doing this. The component migration is about eventually removing the component entity. That's the final goal. And while removing the first phase of the component migration, what we have done for a couple of solvers, Abacus and ANSYS, and I'm sure Dilip is going to talk about what has been done to ANSYS. In OptiStruct, this was never required because in OptiStruct, the component entity itself did not have any solver keyword or solver definitions attached to the component itself. Whereas in Abacus, we did have an element set. So any component in Abacus is, any component in HM is an element set in Abacus. So we had two ways of defining the element set, right? So the component is already an element set, and then you have also a set entity where you can create the element set. Now with this migration, we have removed the attachment of element set to the component. This is the primary goal, and with this, it comes with a little more additional things, which I would talk about in what we have covered in phase 1 in greater detail as we go further into the presentation. For now, the component migration, as I said, is about removing any solver definitions from the components. And why is it required? Um, with the broader vision of our program management, we understand that component has been always nothing but a simple collector of geometry and elements and nodes, FE data, FE mesh. Um, so this has comes with a little bit of issues that we have in terms of our larger goal of moving into a object-based hierarchy, which is like nothing but you would have heard about parts and subsystems, hierarchy that we are trying to move towards for. And why? Obviously, with the parts and subsystems, we have much more better compatibility with the PLM systems, and we can maintain the model pedigree in the CAE domain, and version management becomes very easy. And on top of that, it's also in line with many of our model build workflows, which are much more advantageous for the users as we keep moving in that direction. Some more reasons why. This, as I said, the components and even the assemblies hierarchy, these are giving some of producing some of the hindrance in terms of utilization of our futuristic workflows, and that's primary reason. And more importantly, there is one more thing that we have always thought about is with these components, we had some kind of indirect assignment. Basically, if you had looked at the component entity in the entity editor, you had property and material defined, and you could just directly define the property on the component. That's more of an indirect assignment. Most of the solvers, in the real world, they are the properties attached to the elements, not to you know a bucket, which is nothing but the component. And we want to more move into uh, the streamlined process of directly assigning the property on the elements. Um, Further, for the phase one, what is our goal is, as I said, remove the dependency, and number two, um, for now, we would have the indirect and direct support available, even though there is a slight difference as the solver exported deck comes out, you would see that. And obviously, its component is going to be just a simple connector, of the geometry and elements for the phase one. In the further phases, you would keep seeing that, and eventually the component is being completely removed as well. Final goal, we would have an engineering property and a property control. I mean, obviously, the property has too many, engineering or solver related controls, and we would have a generic engineering property, which is like probably elastic or plastic or more generic property itself as an engineering property, and any additional controls that comes with that would move into the controls of this engineering property, and we would have only direct assignment, directly assign the property on the elements rather than on the component. And as I said, finally we would remove the components and assemblies as we move further. Before going into the phases, I would want to just pick a deck and quickly show you how the difference would be. So in earlier versions, as you can see in 2020, earlier before maybe I think yeah, this was done purposefully. The version that it shows here probably does not make any sense. But as I scroll through, you would see in Abacus, it's always known that when I create a component, the component is nothing but the L set, which is directly on the element definition. So basically, the component is tied with this keyword, and we did have a comment for ensuring that we capture that as a component. The plate is the component here, And when you import this kind of a deck in the current version of 2022, you would see that the element on the component, the component name, which is the LSET, has been removed. And but nevertheless, since the component is still there, we do have a command to capture it in HM for now to still put that plate back as a component while the component exists. Well, that raises the question, what happened to this LSET? As I can scroll down further, um, you would see that the LSET is removed from the star element, but nevertheless, it's not completely removed. You have moved the element, the LSET to the set entity. While doing so, there is one more thing that you guys should probably notice. We were talking about the direct assignment on the element, right? So we captured that, and we instead of using that plate as a direct, indirect assignment of the property, we create um, um, a separate set entity and capture all the elements and use that set entity for the property definition. This can cause some kind of inconvenience for the time being with the users, but as I was saying, this is an interim phase where we are commonizing across all the solvers. So how all the solvers behave in HM today would be commonized with this kind of a change. There is no deck breakage. The deck would still be able to, you should be able to run. There's no difference. Now, it's just that we have moved from the indirect assignment of the property to more of a direct assignment, which is directly on the elements. And this particular LSET, you would not see it on the HM session. This is in a way, but captured in the database. So this is going to be the difference. And let me also explain how this is going to phase out. So in 2022, as I mentioned, we have removed the dependency. We have ensured that the LSET on the star element is removed. The indirect assignment is changed from of the property is changed to the direct assignment. And obviously, we had also have a new import option, which is like by material as well. We used to have by component, by commons, and by property. Now you do have one by material as well. This is again to streamline with within the HM for which is common for all the solver interfaces. Um, as a phase two, which is in 2021 2.2.1, we this particular development is already in QA and should merge soon in .1, wherein we are going to support the legacy HM commons in the sense that if you are importing a 2022 deck, which has been modified based on the component migration, but still some users might really want to have the legacy session or the legacy commons and the legacy way of dealing with the decks in Abacus interface. So we would have an export option which would allow the users to ensure that the old HM commands are written back instead of the new ones, as well as the LSET which is gone in 2022 will be available back in the star element. This is an interim solution to ensure no kind of if there is any users that are using HM commands a lot to do further processing, PR post, whatever it is. One more phase, the phase three. It's a work in progress. It probably can make it to .1 still, but as the development continues, we might have to see how it goes. This is a hybrid-based approach, wherein what we are going to do is there is going to be a property name, right? In the HM session, when you create a property, there is a property name. And when you do a direct assignment of that property on the set of elements, the property name is going to be used as the set in the star element. So the L set which was gone, now it'll come back, but it'll carry the property name. This actually lies in tandem with how a typical Abacus deck is created, in the sense that property can be a hierarchy underneath the subsystems. So in that way, like when you have a subsystem and you have multiple components or multiple parts are there in the subsystem, and each part can have the property displayed underneath, and obviously the set attached to the property would have the property name, and it goes smooth. We have tested with most of the customer decks with this approach as the development continues, and I'm assuming that this would satisfy the users who were known to be using the previous versions before 2022, and that would definitely fit into this as it comes into picture. So I would, if I just want to make a note here, if the users are concerned about our migration process, which can permanently modify the HM binary file as well as Abacus deck, um, I would rather request people to wait for at least .1, wherein um, the the deck can have the legacy comments, which can pull them back to the previous version of structure, or even better, wait for 2022.1, or maybe the next version wherein it will be more streamlined process, and the deck integrity that they are expecting is going to be very well preserved. So this is a major development that we are in doing and in progress as we go further, and it's going to be for all the solvers. And Abacus, being a name-based solver, can have little bit of a not user agreeable situation in 2022, and we are aware of that, and we are making the progress to ensure that it'll be a smooth transition for them as the next versions unfold. So let me move on to other generic enhancements. We have added a few set of keywords like plasticity keyword for, sorry about the misspelling here. For frame elements, we have introduced the plasticity definition. Frame elements are more of structural elements, but it's more of plate elements, I would say. And we do support the frame section definition, and mass adjust is one which is for explicit solvers that we have added. Mass adjust kind of does when you run an explicit analysis, the stable time increment is pretty crucial. If it is pretty low, and it'll take a lot of time to run, so people use mass adjust to hike up that stable time increment by adding mass, which is sometimes probably not realistic, but sometimes it can be like there is always some kind of a mass added in an explicit analysis, which in a model, like say a drop test or something, there is like a lot of other features which we may not model, but we want to include the mass of those, and the mass just really helps us a lot in that aspect to ensure that the total mass is equivalent to the actual mass of that component or a assembly that we are trying to simulate. And finally, there is one more analysis step that we have introduced, which is more of multiphysics that involves a coupled thermal and electrical simulations. Further, there are some keyword enhancements. Deload has always been there, but now we have added traction shear loading for the deload. And uniaxial keyword is is a mode of material definition for hyperelastic material models. You'll have like uniaxial, biaxial, and planar definitions for a hyperelastic rubber kind of material. And temperature is definitely one of the criteria so in there, and we have added the temperature column. And for elastic, there is an additional option called compression factor, which is added. And so for the initial condition with the volume fraction, which is and for amplitude, which is nothing but the curve entity, there's an actuator option that is required for explicit solvers, and that's been added as well. New elements, we have um, the frame that is supported, correct? So we ensure that the frame element types are added, and there was one more quad 4-element configuration called the shear 4 that has been added as well. Well, that's all I had.
Hello all, good morning, good afternoon, and good evening. Today I'm going to talk about, briefly talk about the OptiStruct features available as part of 2022 release. So talking about the high-level overview, so for OptiStruct Interface in 2022, we have implemented electrical analysis, and we have been migrating the bulk cards from the existing entity, which for a better organization, to a new entity. And as part of this bulk card migration, we have migrated the bulk cards which are mapped to load collector to load step input entity. And this is a phased approach, and we have been doing this on multiple phases. As part of 2021.2, we have migrated a handful of bulk cards, and in 2022, again, we migrated remaining bulk cards, and this is going to go on as we move forward in future releases. And from the nonlinear side, we also implemented the contact interference. That's a new bulk card, and some of the generic enhancements are solver card export from the browser and new solver options in the export browser, and a couple of checks added for model checking for the rigid elements. So talking in detail about the high-level overview. So in electrical analysis, this is now available in OptiStruct even before the 2022 release. So now we have implemented the bulk cards which are needed to set up the electrical analysis in OptiStruct. So these bulk cards have been added as part of the interface enhancements. So there are a new set of loads which have been added. Again, to highlight here, these loads are added as part of the new load management, which is creating the loads from the solver browser, not from the panels. And new analysis types has been added as well, and the respective subcase selections are implemented appropriately. Moving on to bulk card migration. So these are the list of bulk cards which have been migrated in version 2022. And you could see here, these bulk cards are mapped to load collector in the past. Now they are migrated to the load step input entity for a better organization of these bulk cards. And within the load step input entity, we have added a few more config type, which defines the respective solver cards. So in this case, you could see the dynamic load, like the R load 1 and R load 2. And similarly, the transient load, T load 1 and T load 2 are added as a separate config over here. And selecting each of these config will show the appropriate solver attributes for the particular card. And as part of this migration, we have also removed the CAA load, which is absolute now in OptiStruct solver, just to highlight on that. In contact interference, this was available in OptiStruct. We added this in interface as a property card. So I'm just showing you how the card looks like in the entity editor. And not just the bulk card, we also added the respective subcase selection in the subcases as well. Yeah, one of the key highlight which I want to talk about here is now user can export a solver card or at the folder level or at the entity level from the model browser. So for example, if you have a list of properties, you could just right click on the property folder and export those properties as a solver deck, and this is applicable for most of the solver cards that will shows up in the model browser. And some of the solver options in export browser for the NVH use cases, we added an option to export the MPC bulk card in the long format, and we already have other solver options which was available in the past release, like the export demog in log format and So what happens here is, I mean, some of the user models, especially from the NVH, there are certain bulk cards which are in long format, and rest of the input deck are in standard format or fixed format. So right now in Hypermesh, we our export templates are mutually exclusive. User can either export in fixed format or large field format. So to handle these use cases, we added the export solver options so that these particular bulk cards can be exported as long format in spite of being the template being the fixed format. And we also, as part of the element ID pool support in the past release 2021.1, we added new HM comments to handle and organize the elements with the duplicate IDs. Having said that, I mean, the model which has been created in the newer version post element ID pool support, the old HM commons has been deprecated. So we were writing out in the new common structure to organize the component and property details. So this was causing when user tries to import the model which has been exported in the later version to the previous version. So in this case, the model organization was lost, and all the elements and the property information is intact, but the component information is organization is lost. So as part of this, we have also implemented from the OptiStruct side to recognize these new HM comments as part of the H3D component organization. However, still when user tries to import the model which has been exported from beyond after 2021.1 to maybe example 2020, we were still losing this information. So to handle this legacy data, so we have added an export solver option to write out the legacy comments like that. That's HMO and HM direct property assignment. And model check, we have enhanced the model check to add an error check and a warning check, which is consistent with the OptiStruct solver. So in this case, you see on the right side image, there are two use cases here where a rigid is completely uh, there's a free node. There's no one of the free rigid leg is not connected to any of the structure. So in this case, we treat them as a free rigid element error check. And if you see the other example where one side of the rigid is connected and the other side is completely partially done. So we added an error check and appropriate warning check, and we also have the auto correction. So in this case, this leg will be deleted, and here in this case, the element will be deleted. And from the post-processing side, extending the HDF5 reader enhancements for OptiStruct and NASTRN as well. So we have enhanced our HDF5 reader to .h5, where we can read the RMS stress results and C-bush stress results, and also element force results from the CFAST elements. That's pretty much what I had to share for what is coming up in 2022. But I also want to take this opportunity to thank the entire team, development team, QA, and the program management for completion these.
Hi, all of you. I'll be talking about solver conversion and ANSYS component migration for which is done for 2022. So before I get into the enhancements done in solver conversion, just to give you a quick preview on the solver conversion workflow and the details. So we actually support conversion details at two levels. One, before conversion, we have list of entities, which gives us an information what is converted and what is not converted. At the end, after conversion, we have a detailed HTML report on based for each entity, which could give us an information about what is supported. And also we have also added unsupported field to this HTML report. So this could give a good input on how do we go about modifying it to get solver results. Moving to the 2022 updates. So basically we had these were four conversions were considered on priority for 2022. One to Abacus to OptiStruct, RAD to OptiStruct, Abacus to Radios, and PAM to RAD. So in Abacus to OptiStruct, we had some critical conversion requests which could help us to get the solver result in OptiStruct. One is friction, and also the combined joins which were introduced in OptiStruct interface were also supported in conversion, which is Cartesian rotation to cart rotor. And with regard to radios to OptiStruct conversion, there was a bigger effort involved in converting these cards as we had to map all the strain rates and the F scale, which is defined on one card in radios card to table MD and arrange them in the ascending order. And type 2, which the contact card was also supported. So similarly, we have for Abacus to radios where we have general contact converted to type 24, type 25. As I clearly mentioned in the conversion installation directory, you will have a configuration file where user could actually go here. For example, in this case, if user wants to convert it to type 25, he has to update it to type 25, save this file and run the conversion. And there were a few requests for PAM to RAD, which were also handled as part of 2022. Moving further, I would also want to talk about basic entity mapping, which is also called as soft conversion, which we never had earlier as part of mapping entities when I switch interface from one to another. So let me just quickly show you the difference between 2021 and 2022. In 2021.2, we had supported soft conversion for component, material, and property. But going further in 2022, we have also extended the support to sets and contacts. I'll show you the difference between 2021.2 and 2022. So this is all about switching an interface from one interface to another interface. So in this case, I have an LS Dyna deck loaded with one of the contacts being node to surface and another one being surface to surface. And all the sets, the basic sets which were not mapped earlier, is also covered in 2022. So if you can notice here, I have these many sets. So I just go to File, Solver Interface, change the interface to OptiStruct. And this is extended to all interface from one interface to another interface. So if you note here, in case of 2021.2, we never had any card image mapped on switching interfaces, which is possible with 2022. Similarly, all the sets were actually basic sets which were mapped on switching interface in 2021.2. There was no basic element set, basic node set, basic part set which were considered, which is handled in the latest release. Let me just run the same recording with 2022. One of them is node to surface, another one is surface to surface. So on conversion, you basically see these node to surface and surface to surface mapped on switching interface. At the same time, you see even the surface segments, element sets, node sets are also mapped on conversion on switching interfaces. So this was the enhancements which was made with regard to soft conversion. So this is how the mapping was carried out across all interfaces. So we mapped the basic context from one interface to another interface. At the same time, the sets which could be mapped from one to other. One thing which we need to make sure here is, make a note of is we don't support formula sets on mapping from one interface to another interface. Moving further, I would like to talk about ANSYS component migration. I think most of the part Vijay has already covered on the reason why we actually do it and so on. But with regard to ANSYS, specific to ANSYS, if you can see here, these are the basic changes which is done as part of component migration. One is dependency on the component. We had HM_comp as the card image, which is totally removed now. And for defining properties, we have a new section entity supported. Earlier, we had contact elements supported on components. This is removed as part of interoperability across interfaces. And one big advantage with component migration in ANSYS interface is there were few element types like solid, contacts, and beam elements, which could have both section and real map to that element. This is possible today with the component migration. And on import today, we will create unique properties with the material and the sensor assignment. Unlike just like other interfaces, which I mentioned, we also support import options by material, property, and one component. Just to show you, I would just want to show you one small example on how the deck would look like with component migration. So earlier, you had HM_comp as a card image. You had property and the element type and material map to component. Now it is just the property, as the eventual or the final goal is to eliminate the component dependency on other properties. So today I could go create a property, say solid 185. So earlier I could only define a real property and assign an element type to it. Now, since we have a new entity called section, I can have both real and the section type defined on that element. I'll just create an element. Create a section. Just one material. So this is the new entity which was introduced. Earlier, this was mapped to section type within the property itself. Now we have split that section type from property to a new entity called section, so that for those elements which require both real and section could be mapped accordingly, as shown in this example. And I can do a direct assignment, which was not possible earlier. It was all indirect assignment. Let's put the stack. So if you note here, I think it is best if I can give different IDs so that we could actually make out the difference. So if you note here, all the ANSYS deck credibility is maintained as is, or as per once with the introduction of new section entity, and by assigning by allowing assigning elements directly onto the assigning property directly onto the elements. So if you can see this material ID, this is the element ID, material ID, section, and real. Earlier, there was only one possibility of assigning either real or section to the element type, which is taken care as part of this migration. Going further, this is the exact thing. And import options by property, one component, and material is supported. So coming to the roadmap with regard to ANSYS interface, we are looking at surface to set migration, supporting embedded entity editor for ANSYS interface. And for solver conversion, we're getting few requests for Dyna to OS, OS explicit, Dyna to OS explicit, and some Abacus to Radius conversion going further. Thank you.